Today we're going to be talking about solving systems of equations using elimination. So the steps that we would use to solve an equation via elimination are as follows. First, we're going to write in standard form. So that would look like ax plus by equals c. Then we're going to determine which variable to eliminate. What that means, so pick a variable for elimination. And the way in which we're going to do that is we're going to make it so that they cancel out when we add them together. So doing that will typically involve multiplying one or both equations by a number. Next, we'll add them together. Add, so this is also sometimes called the elimination step. Add / eliminate. Then we're going to substitute, because after we've added and eliminated, we have a linear equation, we solve it, and we take whatever we get, we plug it back into our system that we started with. And then finally, last but not least, we will check our solution. So, as an example, let's consider the system of equations 3x plus y equals 15 and y equals 4x minus 6. So it's a system of equations. It has two equations, two variables, x and y. And specifically, we're going to start by writing in the form ax plus by equals c. So to do that, I'm going to subtract the 4x over so that I have, if this is step 1, I'll have 3x plus y equals 15 minus 4x plus y equals negative 6. So standard form for each of these equations. Now I need to choose which variable to eliminate. And in particular, it looks like I could eliminate that variable y fairly easily if I multiply either the first or the second equation by minus 1. So maybe I'll multiply that first one, multiply both of these things by minus 1. If I do that, I'll have negative 3x minus y equals negative 15, and that will allow me to add these two together, right? And when I add those two together, that's the adding or elimination step. So this is step 3. Y and minus y are just going to cancel out. And that's really what we're going for, is to take a system that has two variables and reduce it down to a single linear equation that has one. So we add these together, I'll get negative 7x plus y minus y is 0, and this equals negative 21. If I finish solving for x, minus 7, divide both sides by minus 7, so that I get x equals 3. Well, now we have to do our back substitution. Take this and plug it back into either of the two equations that you started with. I think for me, I'm going to take it and plug it back in right here, because then I'll have y all by itself right off the bat. So this is 4 here. We're checking y equals 4 times 3 minus 6. So this gives me 12 minus 6, 12 minus 6, or just y equals 6. So our overall solution here is going to be the ordered pair x and y. So we believe that our solution is 3, 6, x, y. Well, we should check it, and if we're going to check it, I'm going to plug it back into my other equation. So this will be, last but not least, step 5, is plug it back in to my first equation. I'm using the other equation from the one that I solve for y to make sure that I'm getting the most information possible. Well, plug that back in, I'll have 3 times 3 plus 6 equals 15. So this gives me 9 plus 6, which does indeed equal 15. Therefore, we're feeling pretty good that our solution here is indeed the point, or the ordered pair, x equals 3, y equals 6.